This conference will now be recorded.
Hey everybody, it's 2:30 on a Wednesday. It is time for our Monday through Friday podcast that was previously at 1 o'clock and is now at 2:30. Uh, as you, if you've been with us for a while, you know we've been going through the citizens petition page by page, and that's exactly what we're doing today. We're going into the next part of the second citizens petition. In the second citizens petition, we presented 11, let's call them demands of the FDA. What we are asking the FDA to do to begin to take steps to correct the horrendous nonsense and the damage that the FDA has done. Today we're going over requests 5 and 6. We've combined these two together. Okay, just like we combined requests 1, 2, and 3. And again, all we're asking the FDA to do is, FDA, please do what you were created to do. This is why you exist. Okay, you've got so many tens of thousands of employees. You burn so many billions of dollars a year. Okay, and you were given mandates from Congress of what to do. And one of those mandates from Congress is to warn the public. Warn the public. Sound the alarm. Okay, pull the emergency brake. Warn the public. Warn the public if there is something that they need, that the public needs to be warned about, at least from the perspective of public health as it applies to, well, in this instance, drugs, medications. Okay, and while we're talking about it, you are also supposed to protect the public from drugs that could be dangerous. So that's all we're asking in request 5 and 6 is warn the public, protect the public. Warn the public, protect the public. And specifically in requests 5 and 6, what we're talking about here is that there are 3 very good studies done that all kind of did the same thing. Okay, we got 3 very good studies done. The first 2 studies were done with mice. The third study was done with humans. Okay, all 3 replicate each other. Okay, this is real science. This is how real science is done. Replication, one study basically showing the same results as a previous study. Replication of results. That's a cornerstone of science. That's a foundation of science. And doing something in an animal model and then looking to see if it's there also in humans. Again, these are the cornerstones of how scientific research is done. Okay, so this is pretty straightforward stuff here. And the 3 studies that we're talking about are the 3 studies on the screen in front of you. Okay, Dell, Chang, and Kinebaum. Okay, and they all 3 kind of did the same thing. Dell and Chang were back in 1990. Hello, 1990. Kinebaum was in 1998. Nobody at that point in time was talking about some ridiculous brain disease. Opioid addiction is a brain disease. Opioid addiction is a brain disease. No, none of that nonsense existed. Okay, the psychiatrists hadn't pulled their nonsense yet. This is just pure research. Okay, and the pure research back before this brain disease nonsense started, and which, by the way, really started in 1997. But the real research that was going on back in the 90s with opioids was they were looking at adrenaline levels. They were looking at what are called catecholamine levels in the medical world. Layperson knows them as adrenaline. And all 3 of these studies are kind of the same thing. Okay, what Dell did was pretty simple. He took opioid-dependent mice. Okay, mice that when they stopped taking the opioids, they got sick. Opioid-dependent mice. Okay, built a little operating room, put them to sleep. Basically opened up their bellies, immediately put them into opioid withdrawal using naloxone, and saw that as soon as you put the little mouse into opioid withdrawal, the little mouse had a surge in epinephrine, adrenaline. Okay, adrenaline will kill you. Okay, you got to be careful with adrenaline; it will kill you. And here we are in 1990. And Dell showed that when he put the little mouse into withdrawal, the little mouse immediately had a huge surge in adrenaline, epinephrine. Okay, Chang saw that, and in the same year replicated the studies, but also showed that if you surgically ablated the adrenal glands, if you took out the adrenal glands before you put them in withdrawal, you didn't get a surge in epinephrine. So it was very clear that the adrenaline, the epinephrine, was coming from the adrenal glands. Adrenaline, adrenal glands, get it? It's kind of the same word, okay? And there's nothing really complex or hard about this. The adrenal glands are where adrenaline are made and stored, and your body hangs on to it for when you need it. The adrenalines, there are three adrenalines: epinephrine, norepinephrine, and dopamine. They are among the strongest organic molecules known in the universe. I mean, they'll get you away from the bear and the lion. Okay, we all know what that surge in adrenaline feels like. Some of us have felt that little surge, and all of a sudden a little blue light lights up. Never mind. Anyway, we all know what that surge in adrenaline feels like. Okay, but this is an abnormal surge, and that's what opioid withdrawal is and that's why it's so uncomfortable for people. Opioid withdrawal is a loss of the internal organs. One of the organs our people lose control of is the adrenal gland, and get this big surge in adrenaline. How do we know that? Dell showed us. Okay, how do they lose control? Dell showed us that it was a loss of control of the nerve controlling the adrenal gland. Dell showed us. There's no big mystery here. We know exactly what's going on because Dell showed us. Chang replicated it. And then here comes Kinebaum in 1998 and did kind of the same thing with humans. He got 11 volunteers from the methadone clinic, put them to sleep. He was an anesthesiologist, put them to sleep, gave them Narcan, naloxone, immediately put them into opioid withdrawal. Narcan, naloxone, that's what the paramedics carry in their back pocket, given to people when they have an opioid overdose. It will reverse the opioids. But it will put you in opioid withdrawal. And so Kinebaum showed that there was pretty much an identical surge in adrenaline, an identical surge in epinephrine when you give humans naloxone, Narcan. Now, follow me here. This is what we're saying to the FDA. Okay, naloxone has a sister product. Naloxone has a sister. It's called naltrexone. Naloxone. Okay, for most purposes, they're almost identical, except naltrexone has a longer half-life. Okay, and so if naloxone gives you this big surge in adrenaline, if you're opioid dependent, well, naltrexone is going to pretty much give you the same thing. Now, what are we asking the FDA to do? The FDA approved. That's what I'm hearing myself saying this, and I'm in disbelief. The FDA approved naltrexone to use in opioid-dependent people for a drug called Vivitrol. Oh, we're going to cure you of your opioid addiction. That's all going to be in your past. Here, we're going to give you this once-a-month shot called Vivitrol. We're going to give you this once-a-month shot of naltrexone, and it'll deposit into your body tissues, and your body will absorb it over the course of a month, and you won't be able to take any opioids. Okay, and the courts love this. I mean, this is a pretty widely used product. Now, stop and think about it. Okay, we just looked at 3 studies where if you give naloxone, you get a surge in adrenaline. You give a once-a-month shot, a shot that's going to last 30 days. You give a 30-day shot of naltrexone to somebody that's opioid dependent. What do you think it's going to do to their adrenaline levels? I mean, you're right. It's going to run them sky high. Adrenaline will kill you. Now, look at the bottom right there. That's we show this a lot. We talk about this a lot. That's the data from the American Heart Association. We always show the data from before COVID, the 2019 data. And look on the far right in there. You see that since since the opioid crisis started, since 2010 at least, there's been this massive epidemic of cardiovascular deaths. How many of those deaths were from once a month injection of naltrexone? Adrenaline will kill you with a heart attack. Adrenaline will kill you with a stroke. Adrenaline will kill you with a cardiovascular death. Okay, I think that line you're looking at where the deaths are going up there, I think that's all from people going into withdrawal. Okay, people go into opioid withdrawal and dying. And I mean, you're looking at 4 million deaths. Okay, look at the numbers there. Extrapolated out to 2025, you're looking at 4 million deaths. Okay, you're looking at 4 million deaths. How many of those deaths were caused by Vivitrol? I don't know. Okay, but the FDA should not have approved Vivitrol. That's the point. You've got strong scientific evidence that says, hey, don't approve Vivitrol. Okay, because when you give these are called opioid antagonists. When you give opioid antagonists, when you give naloxone, when you give naltrexone, to opioid dependent people, they get a surge in adrenaline. Don't approve that. So we're a bit long today. I apologize for that. But that's the point that I wanted to make is you're looking at how the FDA really dropped the ball here. They never should have approved Vivitrol, not based upon the 3 studies in front of you. Okay, but they did approve it. Why? Because they're following the psychiatrist that's telling you, oh, it's in your head. And they've completely ignored all the science around the adrenaline toxicity. They've completely ignored all the science around the genetic damage. So we're going to hold here for today. I'm not sure if we have Charles with us or not today. Charles,
Yeah, I'm here.
Okay, all right. Charles, you're looking
yes, sir.
You're looking at the 3 studies in front of you right there. You're looking at the study by Dell, the study by Chang, and the study by Kinebaum.
Yeah.
And you can see just as well as anybody can that those every one of those resulted in a surge in adrenaline. Charles, you felt that surge in adrenaline before.
Yeah.
You've been in opioid withdrawal before.
Oh, yeah.
Did you think you might die?
Honestly, I didn't think I was going to die, but I wanted to. It was that bad. I mean, I didn't think I was actually going to die, but I felt like I was dying, and I wanted to die. You know, I would have felt better dead than I was like that. You know.
Charles, it breaks my heart. Absolutely breaks my heart to hear you say that. You're a good person, Charles. You've always been a good person. You didn't ask for this, and for you to have experienced that, it quite honestly, Charles, it angers me. I'm mad. To hear you say that angers me.
Yeah, well, I mean, that's just part of it. You know, you found this out, and you're trying to help, and that's all you can do. And I appreciate it. I mean, like you
Charles,
said, you remember that fellow that you told me had just gotten out of jail? He
yeah,
had taken and went and tried to rob a pharmacy,
3 of
or
them.
had, yeah. Um, he's. I can tell you right now, everybody that's been in this position has thought about that. I've thought about it, and I never considered getting away with it. I just wanted to get in there and get it. I didn't
The
plan on
withdrawal
getting
was
it. Yeah,
the
I didn't plan on getting away or nothing, you know.
withdrawal was that bad.
Yeah, yeah.
Charles, I'm going to ask you a question, and this is not a fair question for me to ask you because I haven't given you time to think about this. Okay, but based upon what you just said, okay, this is a question I've been carrying around in my head a long time, and we're long today. We're gonna have to call it quits, so maybe we'll get into this tomorrow. But Charles,
Yeah.
here's my question. Okay, I've never experienced a loss of control of my internal organs. I've never experienced autonomic dysfunction. I've never experienced what you've lived through. I've never experienced that multiple day surge of adrenaline. I've never experienced. I don't know how, but my guess is I wouldn't be any different from everybody else. It probably does eventually. Everybody's sudden is kind of in the same bucket.
Yeah.
So here's my question. Do you think there are some people that the withdrawal could be so bad, so horrible, that they could commit a crime that they otherwise would not have committed? And Charles, here's my question. Could somebody commit murder because the withdrawal was so bad? And if the only way out of withdrawal was to kill somebody and get something and take it, do you think the average person would be capable even of murder in that situation?
It's possible.
Here's why I'm asking.
And I hate to say that, but it is possible.
Here's why I'm asking, Charles. Alex Murdaugh, the guy in South Carolina that killed his wife and son.
Yeah.
Was he in withdrawal when he did that? Did they
You
take
know,
away?
I don't know.
Anyway, let's hold there. Charles, we're always thankful when you're here. On the days when you can't make it, Charles, when you're here, you're great, but we understand when you're not here. We're going to hold here for today. Everybody, like and subscribe to us. Place this podcast on your social media and everybody else's social media, and we will be back at 2:30 tomorrow. And Charles, thank you very much.
No problem.